So on page 2, we are given some data about some test scores. I'm not sure, are these the same test scores from the front? Oh, yeah, they are. Okay, so I was wrong. I guess we are using that data from the front. So we are now asked to create a box and whisker plot for the test scores. And something that we do when we make a box and whisker plot, and I'm pointing this out because we're asked to do this later on somewhere else in the study guide. Down here in question 17, we do what's called the 5-number summary. And so the 5-number summary is going to be where we identify the minimum of the data, the maximum of the data, the median of the data, our first quartile, and our third quartile. So looking at the data, what I'm going to point out is that it is not already in order. So the first thing that we want to do is reorder our data. So it looks like 16 is the lowest test score, then 18, then 20. I'm going to cross these out as I go so I don't miss one or repeat one. 28 is after that. Then let's see, 36, 45, 49, 57, 63, 65, 87. Okay, so now if we look at this, our minimum value is 16. Our maximum value is 87. And to find the median, what I like to do first is I count up how many data there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 test scores. So I know I want that middle number. So since half of 11 is 5.5, I want to go in like 5 pieces of data to find my median. So 1, 2, 3, 4, 5. My median should be 45. I can double check by going 1, 2, 3, 4, 5 from the other direction. 45 is in the exact middle, so that's the median. So now when we are trying to find our first quartile, it is now going to be the median value of our just left-hand side of the data. So if we consider our data to the left of the median, we have an odd number of data here. And so it's really like I'm finding the median of this data set. So I could see these are already in order, that my middle value there is 20. We do the same thing on the right-hand side of the median. And so the median of this blue data set is our 63. So those are our Q1 and Q3 values respectively. So this over here is what we call the 5-number summary that we do need to think about when we make our box and whisker plot. And so I like to start with the box. So remember, the box goes from Q1 to Q3. So from 20 to 63, which we're just going to kind of ballpark about here on our number line. That is where my box goes. The median we said is 45, so the median is the bar in our box. The max is 87, so we kind of go out to approximate 87 on our number line, and the minimum is 16. All right, so that is our box plot for number 8. In question 9, we're asked to describe the shape, center, and spread of the data above. And it says only complete the before Marcus column. So I wonder who Marcus is. I bet we will find out in a minute. So when we talk about the shape of our data, if we're looking at a box plot, what we would be determining is whether or not there are outliers. And that is something that we're more likely to do when we already have a box plot. So I'm just going to tell you now, there are no outliers. So that's all I'm going to really say for the shape. There are no outliers. We can determine outliers by taking our interquartile range. So remember our IQR, that's where we do Q3 minus Q1. So 63 minus 20, which is 43. And if I multiply that number by 1.5, and if you're like, wait, when did we do this in class? We honestly didn't. But if I multiply my interquartile range by 1.5, so 43 times 1.5, I get 64.5. So I would have to subtract that from Q1, which would be a negative number, or add that to Q3, which would be like 120 something, close to 130. That would give me the range of where my outliers are. So all that to say, we don't have any negative data. We don't have any data above 100, so no outliers. The center of our data, well, if you wanted to, you could find the mean, but what we could describe right now is the median. So we could say that the median is 45. And since it's good to remind ourselves how to find the mean, let's find the mean. So we just add up those 11 numbers and divide by 11. So 16 plus 18 plus 20, plus 28, plus 36, then what, 45, 49, sorry, I should have done this before I was filming, 57, 63, oops, that was just the 3. I hope you are doing this at home along with me. 65 and then 87. Okay, so we get a sum of 484. And again, since we had 11 numbers we just added, we divide that by 11. And we get that our mean is 44. So our median and mean aren't too far apart from each other. All right, when we talk about the spread of data, remember we could be talking about range, interquartile range, or standard deviation. And since we weren't given the standard deviation, let's just discuss and say like our interquartile range is, we already found that, so it's Q3 minus Q1, or in other words, the length of the box right here, that's our IQR. So our interquartile range is 43, and then our range is just the max minus the min. So our range is 87 minus 16, so 71. Okay, so Marcus joined the class a week before the test. He didn't study, but he scored a 95. What? Marcus must be a genius. So what should happen to the mean of the test scores, and why should this happen? So if I think about this, if Marcus's score is above the mean, his score is like adding his score to our data is going to change the mean of the data, and it's going to pull it in his direction. So what should happen, well, if we include a really high score, the mean should increase. And we have no way of knowing exactly by how much unless we recalculate it. So now we're asked to add his test score to our data and make another box plot next to our original. I didn't leave a lot of time for that, or a lot of room for that. And we're gonna fill out the after Marcus column. So if we just go back to our original data, I'm gonna delete my 5-number summary over here because it's gonna change. But what I'm not gonna do is delete all the data here. I do wish I could easily unhighlight this though. Can I? We'll find out. Maybe not. Okay, we might have to ignore the highlighting. So when I now add his test score, I'm going to add it at the end because it's the high score. We now have 12 pieces of data. So now when we're finding the median, his addition is in the higher set, which means 45 is now in the middle set of our data. So now, since we have an even number of data, we have 6 data points here, 6 here. And so now we have no middle number in our data set. So to find the median, we're just now finding the point that is halfway between 45 and 49 on the number line. And you could either like add those numbers together and divide by 2. That's one way of doing it. Or you could think, all right, 45 to 49, that's a difference of 4. So adding 2 or subtracting 2. So one way or another, 47 is our new median. 47. Our minimum score didn't change. It's still 16. Our maximum score did change. It's now 95. And we've got to recalculate Q1 and Q3 again. So now when I'm finding Q1, remember now the left-hand side of my data, I have an even number of data. So I'm looking for my first quartile to be between 20 and 28. So we can see that Q1 is going to be 24. So again, it's like the average of 20 and 28 or the median of 20 and 28. And Q3 is going to have to be right here. So 64. So I've got 24 and 64. Okay, so now because I ran out of room, I'm going to erase this data to put my other box plot on top of the one that I drew already. So now our score that includes Marcus's data, our box is now going to start at 24, so about here. Our box goes up to 64, so about here. And now our median, we said, is 47. Oops. Our maximum now with his data is 95. Our minimum didn't change. So the purple graph is with Marcus's data. All right, so there are still not going to be any outliers, and we otherwise really can't talk about the shape of the data from this distribution unless we make a different one. The median went up, so our new median, we said, is 47. We need to recalculate the mean. So remember, the mean before was what? 484 divided by 11, I think. We got 44 for our exact mean. So I'm just going to multiply that back by 11 to see what some of our data was. Yep, 484. So now if we add Marcus's 95 to that, we could now divide that number by 12. So 48.25. And if what I did doesn't track, you could just find the mean again, like add up all 12 numbers. So 48.25 is our new mean. And then for the spread, well, both our IQR and our range change. So our new interquartile range is 64 minus 24. So just 40, IQR is 40, whereas our range is still max minus min, so 95 minus 16. So let's see, what is that? 79. Okay, so our range increased, but our interquartile range decreased. So when we look for any changes or observations in our table, well, the fact that we didn't have outliers, there was no change there. Adding Marcus's data slightly increased the median, but it more greatly impacted the mean. So it increased both the median, I'm going to say slightly on the median. Sometimes adding one data point doesn't change the median at all. And it increased the mean. And that is a little bit more noticeable of an increase from 44 to 48.25. What's interesting is that the range of the data increased, but the interquartile range decreased. So now the middle 50% of our data is less spread out. But adding his point as the new max increased the range. All right, so anything we want to say to hold our thinking there?